Alright, so this video is going to be focused on a kind of minor but an important point in our free body diagrams, and that's on the difference between forces being equal and balanced and how we use tick marks to show that forces are in fact equal or maybe aren't equal. So first, let's talk about forces being equal and how we use tick marks there. So a lot of times we'll show like a force of gravity, and if an object is on the ground or a table or some kind of stable surface and it's not accelerating upwards or falling downwards, then a lot of times we will show an equal force acting upwards. And we might show those two forces as being equal to each other. Now, we could also have possibly two forces acting towards each other or like sort of with each other, and those could also be equal. And I mentioned this in the free body diagram intro video, but the number of tick marks that we use is completely arbitrary. I could have put 50 and a million tick marks on either of these pairs. The only important thing is that we put the same number of tick marks on forces that are equal to each other. Now, that's different from forces being balanced, because for forces to be balanced, they don't necessarily have to be equal. And an example of that is if we have some heavy object, and now I'm going to start putting numbers to some things. So let's say that our force of gravity were 100 newtons. So once we work with more quantitative free body diagrams, you'll get more comfortable, or this might be more familiar putting these forces on there too. But we could have forces that balance this. Let's say two people are working together to lift this object. And so one person applies a force of 50 newtons, and another person applies another force of 50 newtons. And so in this case, we actually have these two forces are equal to each other, and all of the forces acting on whatever object this is are balanced. And just as another example, those two forces do not have to be equal to each other. So we could also have a 70 Newton force acting here and a 30 Newton force acting to sort of aid this 70 Newton force, and the forces acting would still be balanced even though none of these forces are equal. And so I'm not going to use any tick marks in this example, because even though our forces are balanced, none of them are equal to each other. 70 is not equal to 30, is not equal to 100. So no tick marks in an example like that, even though the forces are balanced. And you'll notice over in this purple example, in our example where we have forces that are equal, these forces are not balanced by anything right now. Our normal force and gravity force are balanced out by each other, but right now we have two forces acting together and they're equal to each other, but they're both acting to the right, and there's no force that's acting back to the left that is canceling that out. And in fact, this one force, if there were one, would have to be, of course, twice as strong as both of these to cancel out or to balance out both of those forces acting. But this is just a very quick, hopefully maybe clear demonstration of the difference between forces being balanced and forces being equal.